Today we're going to talk about reinforcement learning. The idea of reinforcement learning is we're looking at what an agent should do. Now, to define an agent, we have to define the prior knowledge, the observations, and the goal. So in reinforcement learning, the prior knowledge is the possible states of the world and the possible actions. So that's all we know of at the start, but we have to provide these. We have to say what are the states of the world and what actions are available. What we're going to observe is the current state of the world. The agent's going to observe at any time the current state of the world and any immediate reward or punishment it has received. The goal is to maximize the accumulated discounted reward. Okay. So that's like our model of decision theoretic planning, except in decision theoretic planning we had to provide the dynamics, the probability of the state given the previous state and the action, and the model of the reward, how the reward depends on the state and the action. Instead of having these as part of the model, we're going to learn them. So here are some examples of reinforcement learning. So you can imagine in a game we're going to reward winning and punish losing. So every time you win you get a reward, and every time you lose you get punished. Most of the time we actually do more than that. We have small actions we're going to reward. In a dog you could imagine rewarding obedience and punishing destructive behavior. So you could imagine a robot rewarding task completion and punishing dangerous behavior. From just these rewards and punishments and observing the state, we want to work out what the agent should do. So the idea is that we're building on is the idea of a sequence of experiences. This is what the agent gets to observe. The agent gets to observe a state. It was in a state, it carried out an action, it received reward and has entered a new state. It carries out a new action, receives a reward and then is a new state, and so forth, and it keeps going on. Okay. The sequence of experiences, these state, action, reward sequences, up to the time the agent has to choose its action is called its history. So we're going to talk about the history of an agent is the state, action, reward, until now. And the agent has to choose its action as a function of this history. At any time, however, the agent has to decide whether to explore to gain more knowledge or to exploit the knowledge it has already discovered. If you imagine going out to a restaurant to eat, you've got to decide whether you want to try a new restaurant or to explore to try a new restaurant or to go to the restaurant you like. If you keep exploiting the restaurant you like, you might miss out on finding something you like much better. And if you explore all the time, then you'll end up at just sort of an average restaurants on average. So you won't be able to keep going to the one you like, the best one. Okay. Reinforcement's hard for a number of reasons. So the first reason is what actions responsible for reward may have occurred a long time before the reward was received. So we have to work out, given a reward, why did I get that reward? An example is that if you say at the end of the day your dog, it's a bad dog, and the dog has to work out what it is that it was bad for. And the dog's expected to determine that eating the shoe at the start of the day is what was responsible for being scolded at the end of the day. And as you can imagine, that's complicated because it's got to try and work out, everything it did in that day and see what was it that was responsible for being scolded. Moreover, actions aren't bad in themselves, but depend on what it is you're going to do in the future. The long-term effect of an action depends on what the agent will do in the future. So if an agent has to tidy up a room, it might be bad if it creates a big mess, but that might be the best way to tidy up because you create a mess and then you clean it up. So it might be okay for the robot to create a mess as long as it cleans up after itself, but if it doesn't clean up after itself, it might not be okay to make a mess. So it's difficult here to work out actions depending on what you're going to do in the future. So there's complex interaction between actions and time and planning. And there's also the explore and exploit dilemma. At each time, should the agent be greedy or should it be inquisitive? Should it try and be greedy and say, let's do the best thing I know about, or should it try and explore more and be inquisitive? So a number of main approaches to reinforcement learning. The first one is to try and search through a space of policies. Or as we saw before, these are controllers. So what you're going to do is you're going to try and change your controller. The controller is a function from the state into action until you get a better and better controller. So there's a whole class of algorithms that do that. There's a class of algorithms that learn a model consisting of a state transition function. So you can learn the probability of the state given the previous state and a reward state the reward is a function of the state, the action, and the following state. And then once you know the state transition function, the reward, you can solve this as a Markov decision process, as we did in decision theoretic planning. And the last one we could do is we could learn Q and S and A directly and use this to guide action, because if you know Q of S and A, then we can exploit just by choosing the A that has the maximum reward for any state.